Hello, this video covers the mole. The mole is a very important concept in chemistry. And mole is just a word we use for a number, just like we use the word a dozen for 12, or the words half dozen for 6, or pair means 2. Well, mole just means a number. And a mole means 6.022 times 10 to the 23 of something. So if we have 1 mole of atoms, we have that giant number of atoms. Again, we don't want to write that giant number, so we write it in scientific notation. This giant number here and 6.022 times 10 to the 23 are the same number. They're just written in different formats. Now we use the mole because atoms are so incredibly tiny. We can't count just one atom, but we can count 1 mole of atoms. So the analogy I use, let's say your job is you work at an egg farm and your job is to count eggs. You'd much rather count those eggs by dozens than by each individual egg. It's going to take a long time to count 1 egg, 2 eggs, 3 eggs, but you're going to be much more efficient, much quicker if you go 1 dozen, 2 dozen, 3 dozen, 4 dozen. Well, so you're counting in chunks, so that speeds things up, makes it more efficient. Same thing in chemistry. But those chunks, since the things we're counting, these atoms, are so incredibly tiny, the chunks are really big. So the chunks we count atoms in are these moles. So we count 1 mole of atoms, 2 moles of atoms, 3 moles of atoms. And we can do this very easily because of some information on the periodic table. According to the periodic table, 1 mole of carbon atoms has a mass of 12.0107 grams. It's the red number on the periodic table. I'll show you here. So look at carbon, and we see carbon, we have 12.0107. It's the red number on the periodic table. If I had 1 mole of boron, it would weigh, or have a mass of 10.811 grams. If I had 1 mole of nitrogen, I'd have 14.0067 grams of nitrogen. So that's what that red number on the periodic table is. It tells us if we have 1 mole of that element, what would the mass be? We call that molar mass. It's the mass of 1 mole. And we'll apply this later on to molecules. We'll show you that in a second. The unit for molar mass is grams per mole. You'll want to remember that. So here's an example. How many moles are in 15.9 grams of carbon? Well, this is a conversion. All we're doing is converting from grams to moles. So just like we learned a couple units ago, conversions, we look for our starting number, and we follow that by a conversion factor. So starting number is 15.9 grams. So that's the first thing I write here, 15.9 grams. If you want to write C for carbon, that's fine. Times blank line. Starting unit, the grams, always goes in the bottom. So whatever we start with always goes in the bottom. In this case, we're starting with grams, so grams goes on the bottom. What we're looking for always goes on top. In this case, the question asks for how many moles. So moles goes on top. And MOL is the abbreviation for mole. I know it's kind of silly just dropping 1 letter, but that is the abbreviation for mole. Now we have it set up just like any other conversion, same pattern we've already learned. We just got to figure out what numbers to put where. Now the nice thing here is mole is always 1. Whenever we have mole, we put a 1 in front of it. Whenever we have grams, we put the red number from the periodic table. So what I do is I see we have carbon. So I look up on the periodic table and I see the red number for carbon is 12.0107 grams. So that's what I put in front of grams. Do that math, I end up with this big long number, 1.3238, blah blah blah. I look back at my starting number, I see my starting number has 3 sig figs, so my answer should have 3 sig figs. So I cut that off at 132, I cut it off right there. The 3 is not going to change the 2, so my final answer is 1.32 moles. Let's do another example here. I'll work this one through with you. So, actually, if you want to try this one, you can pause it now, and then check your answer. Or if you're not sure, just follow along. So my starting number is 24.3 grams. And I have phosphorus times blank line. In this case, starting unit is grams, so grams has to go on the bottom. I'm looking for moles, so moles goes on top. Mole, whenever I have mole for a unit, I always put a 1 in front of it. Whenever I have grams for a unit, I put the red number. Now the red number, when I look it up in the periodic table, is 97336. It's hard to write with this thing when you're not looking at it. Okay, so I do that math. 24.3 times the top number, divide by the bottom number, and I get that big long number for an answer. 0.784535. It keeps going. Starting number has 3 sig figs. Answer should have 3 sig figs. Zeros in front are never sig figs. Remember that. So 784. I'm going to cut it off right there. But that 5 is going to change that 4. So my final answer is 0.785 moles. Again, the 0 in front is not a sig fig. If you left it off, that'd be fine. If you said 0.785, that would be fine also. You don't have to have the 0 out front. So, hopefully that makes sense. We will be doing a lot of this type of calculation throughout the course. And you'll get more practice with the practice quiz. The concept of molar mass also applies to molecules. And what I mean by that is if I said the molar mass, what is the molar mass of phosphorus? You would say 30.97376. Well, what if you have more than one element? Here I have, what is the molar mass of H2O? Well, I got 2 H's and 1 O. So what I got to do is I got to look at the red number for H and the red number for O. Since I have 2 H's, I multiply by the red number by 2, because there's 2 of the H's, and then add that to the O. So I have 2 hydrogen atoms. It's H2. 2 hydrogen atoms, so 2 times the red number, and I get that answer. I have 1 oxygen. Remember, no number means there's a 1 there. We all know it's there. We don't write it, but we all know there's a 1 there. So 1 atom of oxygen times the red number. Get that, add them up, and we get 18.01528 grams per mole. Again, the unit for molar mass is grams per mole. We don't typically do sig figs for molar masses, so whenever you get a molar mass, just leave whatever the calculator says, go with it. Okay, so what is the molar mass of Al2O3? So, aluminum. Well, I've got 2 aluminums, and the red number for aluminum is 26.981538. Oxygen, well, I've got 3 oxygens, so 3 times the red number for oxygen, 15.9994, and then I just add all that up. So when I add all that up, I get 101.961276. And again, the unit is grams per mole. So, fairly straightforward there, just finding the red numbers for each thing, multiplying it by how many there are, and then finding the total. Next example is kind of combining these two concepts. So let's look at this. We have, question says, how many grams are in 4.27 moles of MgOH2? So I look at that, that's conversion, I'm given moles, I'm looking for grams, moles to grams conversion, I can do that. So starting number, 4.27 moles to conversion, so times blank line. Starting unit, whatever you start with, always goes on the bottom. We're starting with moles here, so moles on the bottom. We're looking for grams, so grams on top. Mole is always 1, grams is the red number. But since I have a compound, this is going to take some work here. So I'm going to have to take the red number for mg. The 2 multiplies everything on the inside, so I have 2 O's and 2 H's. So I'm going to do that math real quick. mg, I got 1 times 24.3050. And for oxygen, I have 2 of those. Hydrogen, I also have 2 of those. I'm going to do all that math, add those 3 answers together, and I get an answer of 58.31968. And I take that number, and that's what goes in for grams here on top. 58.31968. When I do that math, I get 249.025, keeps going. Look at my starting number, I got 3 sig figs, so 1, 2, 3, going to cut it off right there. The 0 is not going to change the 9. So my final answer is 249 moles canceled moles. So grams is my final answer, 249 grams. Again, to do that math, I took 4.27 times the top number, so times 58.31968, divided by the bottom number, and that gives me my answer there. So hopefully that's kind of making some sense. Kind of running low on time on this video, so what I'm going to do is I'm going to pause it here. What I recommend you doing is also pausing it. Do this example on your own. So pause it, do this example, and then when you unpause it, you'll see my work. I'll explain it real quick, and you can check your answer. So if you haven't paused the video, pause it now. So this is what your work should look like. Your final answer is 0.5390 moles. So the first thing I did, 167.2 grams times blank line. Grams goes on the bottom, moles goes on top. 1 mole. And the 310 number I got over here. Now the tricky thing about this question is there's 3 calciums. The 2 on the outside of the parentheses multiplies everything in the parentheses. So 2 phosphoruses. 2 times 4 is 8 oxygens. The 2 is only for the phosphorus and oxygen. The 2 doesn't change the calciums at all. So you got 3 calciums, 2 phosphoruses, 8 oxygens. You find the red numbers for those. You total them all up. You get 310.17672. That goes in the bottom. You do your math. You do sig figs. You end up with 0.5390 moles. So hopefully you got that. If you did, good job. Again, you will get more practice with this on the practice quiz. Thank you.